And so Stacy's back to share some more insights. So welcome, Stacy.
It is such a privilege to get to speak to you guys today. Can everybody hear me okay? All right, excellent. I can get a little soft-spoken. If you think either you're losing your hearing or I'm not talking loud enough, please let me know. It is great to get to talk at NC State. It's great to talk to computer science because, as Lori said, I came out of this program. You guys, I feel a lot of empathy for you because I was in computer science as an undergrad and did some graduate work in it as well here. And let's just start with, a word from the corporation. If you think you hear product direction or any sort of promises in here, you didn't at all right? No promises, no guarantees applied or expressed, but we will talk a little bit today about Watson. And I always tell people, and I've been saying this probably for the past 20 years, I have the best job in IBM. And if I ever start to feel like I don't have the best job in IBM, it's time to go find something else to do inside the company. And you guys, how many folks would one day like a career? There we go. That's why you're here, right? So we will try to talk a little bit. I'll try to throw in a few things to talk to you guys as NC State computer science graduates, hopefully soon, and talk to you about career and technology choices because I've been in the industry for a while. When I was at State, let's see, this sort of summarizes my NC State experience. I did borrow, Ken, a couple of pictures of the building. There was no campus over here. There was woods, basically, over here. Some of the streets I drove on to get here today didn't exist. And there was a new young professor who had just joined the department. His name was Mladen Vok. He was the new young Turk of the department at the time. And I spent my days kind of moving from my RA job because I was a resident advisor in Bowen. I lived on the top floor of Bowen, which I remember the elevator being out a lot, right? A lot, and lugging particularly laundry from the machine down in the ground floor up to the top. And you would think for all that I would have been in phenomenal shape, but for somehow that escaped me. I also learned a lot about locks working as an RA. You'd think I'd be better at security, but I spent most of my time getting people who had locked themselves out back into their rooms. And then I would go off to Daniels, which is where computer science predominantly was at that time, and we would go through a full day of lectures, and then I would go off to Laser Hall. I spent more time in Laser than any other place on campus because at that time you couldn't take the computer home with you, right? You went to where the computer was, and we're going to talk a little bit about how that has changed a lot and how that sort of change is going to happen in the business that you're about to embark upon. You're about to become programmers, software engineers. You're about to enter the world of IT. And I think because of the work that we have done with Watson and some other work that's going on in the industry right now, that is going to be a very different space than it is from where you're sitting today. Just like my forays to Laser, I almost brought, I dug up one of my old floppy drives. You used to have to print off your homework on with the dot matrix printer and include it with a floppy drive, big paper clip, and turn that in for your homework, and you'd have to stand there hoping you would pick the printer that was actually going to work. And since you were sharing servers, the people who had the pointer homework, right, people who had to do references and pointers, they would crash that thing every single time. So first thing you did when you sat down, you said, does the printer work, and what homework are you working on? And if you got wrong answers to any of that, you had to get up and move if you could. I also co-op for IBM while I was in school, and if you get an opportunity to intern, one of the interns who's working with us in Watson, Holly Christensen, is down here at the front. I would strongly recommend it. It helps you understand more about the job that you're going to be doing day by day when you get out in the industry. And also, it's a good opportunity to see the company itself. What I really loved about IBM, and I still love about IBM, is we're very career focused. We're very interested in growing talent inside the company, right? So we're not looking for, you know, let's bring this person in and then, you know, maybe 5 or 6 years from now, we'll have to, we'll see what they can and can't do with that. Don't worry, we got it. All right. This will encourage me not to spend too much time on one chart, but we spent a lot of time in career development for our employees, and that was evident from my co-op experience, right? People cared about what you were working on, they cared about whether you were happy about what you were working on, and they cared about your skills and improving and growing those. So I learned a lot as a co-op student as well. IBM Rtp, how many folks have been out to IBM Rtp? A lot of you guys. You should definitely look for opportunities to do that. We do host a lot of student events. We have mentoring programs that we do with NC State. It's the largest site in North America, right? So it is a good representation of what IBM's all about. We are also very big on patents, and Rtp people are on 12% of those patents. That's a huge number. We have, I've been to events where they've had a couple of folks stand up and they go, these 4 people standing here have as many patents as, and they name some companies, right? We strongly encourage our employees to patent. We strongly encourage innovation, and Rtp is a good place for that. Lots of people on boards, Agile Space, and I think for you guys, this might be particularly interesting. About 1/3 of our folks have been with IBM less than 5 years. So it's perhaps not the IBM you've come to know and expect. We have a lot of new young folks in the company. They have wonderful activities planned. I haven't quite figured out how to hijack some of these, but I'm going to do it one day. For myself, I did start out, the family was quite impressed that I got a job breaking things as a co-op student. I was in testing. And I was really good at it. I can break anything, really. It was a talent. The developers would come by my cube and say, you need to take a long lunch today. We're dropping new code, and we don't need you finding all the bugs and writing them up for us. So you're going to a long lunch? And I'm like, yeah, make that happen for me. And you know, so we had a good relationship. I went into software engineering tools. I built tools for software developers. I learned a lot about good software development through that process. And then I took a short career detour into map making through GIS. That was kind of interesting, but not really my core strength. And then, and this is always the part when people ask, how did you plan your career? I didn't plan my career. I went to things that were interesting and I thought were good jobs. I ended up on WebSphere, which turned out to be the fastest growing software product in the history of the company. And that's a lot. We've had some really good software products, and that one took off. And that's also where I picked up performance and capacity planning, learning not only about how to build software, but how software sits on computers, how it sits on data centers, how you can get the capacity you need to get through Black Friday, which is when I ended up with the retail team. And helping people start their planning early in the year to meet the demand later in the year. Because at that time, we didn't have cloud. We had the concept of, you know, all your stuff's in your data center. And these poor souls who just a few months ago were worried about point of sales terminals now have to figure out how to deal with a high transaction, high volume website that's generating millions of dollars of revenue for their company if it will only stay up. And so, and you have a very short window, and people don't come back if things go wrong. So, a lot of fun, a lot of stuff on the line, something that no one had ever trained me to do. I had to sort of learn it. A lot of folks inside IBM who were happy to help me with that, and really enjoyed that experience, except for times when it wasn't terribly enjoyable, but that's another story for another day. And then on to Watson. And the reason I went to Watson was this seemed like an opportunity to really deal with the next wave of computing, the next wave of change that was going to come through our industry, because we really are in the throes of a new revolution here. Again, when I started, you had to go somewhere to find the computer, or you had this big honking device with very little power that sat on your desktop. And when they first started selling home computers back then, do you remember what the rationale was that they gave you that you would probably want to buy one? There was recipes, right. You're going to put your recipes on this. The killer recipe app has never shown up. I think we're kind of at the point where we could do it with unstructured data, but people got these things and said, I'm not sitting here typing in all my recipes on this thing. This is nuts. But playing games, that worked out really well. Taking care of your financials, that worked out really well. And then the network itself began to improve dramatically. We went from call-up to other types of network into your home, and that opened a whole set of opportunities for what we can do with computing. And now, I've talked my mother into giving up her much-beloved flip phone just a couple of years ago. Like, I love my flip phone. I'm like, well, what if I could get you a computer that has a phone on it that you could carry in your pocket? Ah, that's what we have, right? We all carry around a computer with a phone in our pocket. And that's changed everything. Now, interestingly enough, we're busily pushing our data back into places that are remote to us, but we couldn't do that before. The software, the network, many things have improved that allow us to get there. And so that's the next frontier, right? We have this data that we're generating with all this new capacity and new devices that we have available to us. And what are we going to do with it? How many folks saw the 60 Minutes show with Watson, the episode that featured Watson? Okay, so, well, that tells me a lot about their audience segment. So one of the highlights in that show was the UNC Oncology Program. So UNC Health, just over there, uses IBM Watson to look at the thing up in the upper right corner, new cancer articles. There are, thankfully, a lot of people spending a great deal of money trying to solve the problem of cancer and looking at different treatments and different options for different types of cancer. And the way this is traditionally handled in a hospital, if your loved one or yourself end up in that terrible situation, they get as much information about the cancer as possible. What is it? Different parameters about it. It's genetics as much as possible. And it goes before something called the cancer board at the hospital. This is a team of doctors who are trying very hard to keep up with the latest research, to think about how we could best treat that. What is available? What are new treatments, new ideas that we could use to solve this problem, to help you get better? And what we did with them with Watson is we took these articles that are being generated and we trained Watson how to read them and how to understand the parameters of cancers that would be fed to it. And what we found is that Watson agreed with a vast majority of their recommendations, them being the cancer board, but it also found things that they didn't know about in a significant number of cases, right? There were additional studies, additional treatments that could be brought to bear. And so what's the risk of not understanding all this data that we're generating, that in the case of cancer research, that we're spending a lot of money trying to defeat this terrible illness? Well, it's missing opportunities, right? It's missing opportunities to crush this foe that we have. We also have a lot of video that's coming, right? 500 hours upload every minute. This This lecture will only seem like it lasts 500 hours, so don't worry. You know. So what do we do with video? Wouldn't it be great if we could search not only some information, that some company has hired someone to watch the video and type in tags and various things, but wouldn't it be great if we could index on the video itself? And we have been involved in that work using video from TED Talks and other places to not just look at having a human annotate it, but to have Watson itself listen, understand the language, and annotate. So the unstructured data that we have available, we're slowly starting to break that down and get a better understanding on it, because this data, strangely, does not march in and line itself up in a SQL table, right? It's not been terribly cooperative that way. A lot of it's unstructured, a lot of it's in formats that we've never considered before, a lot of it is coming in enormous volumes. Oh, wait, there we go. All right. So the interesting thing about humanity is about our problems, right? As we encounter things that are problematic, we have too much that we can handle on our own, or we have opportunities to spread out into different places, something comes along to help us, right? So we went and played Jeopardy, and you're going, okay, how does this come about? So this is another thing that you guys might be interested in, particularly those of you who are looking for PhDs or advanced degrees that would lead you to research, is that our research organization thinks about what do we have that's kind of close to a place that if we really set a hard goal for ourselves, we could move forward. We can move the science forward significantly. We feel like things are coming together, but they're coming together in different streams. How do we pull those streams together to move, to make the leap? And this was bold. They said, we're going to teach the computer to play Jeopardy. I can't play Jeopardy. You know, have you ever, how many folks have sat and played Jeopardy? Again, market segmentation. You got to go hang out with your parents. Come on. This is a holiday treat at the house, right? We all end up watching Jeopardy and trying to guess the answers, and not easy. So do you guys know the format of Jeopardy, right? You are given a fact, and you have to respond in the form of a question. Is there any limit on the topics that are involved? No, it can span, you don't know the topics that are going to be present. It took us 4 years to prepare. That's a bit of a misnomer or a misstatement because some of my colleagues who were involved had worked in natural language processing and other things for most of their careers, right? So we had been studying the science for a considerable period of time, but 4 years out, we decided, let's set a challenge for ourselves. We're going to be a contestant on Jeopardy. And we had to audition just like any other contestant. No special treatment because we're a computer. And Watson was actually at that time 4 computers, 4+ computers. It was an array of computers that were built to respond to Jeopardy. We've come a long way since then. And that's one of the things that we were multiple computers that responded to a fairly specific test case. Our next goal was to make this technology available to business. And in order to make the technology available to business, you have to kind of strike a balance, right? And if you guys have, how many folks are studying AI? Okay, my first exposure to AI was here at NC State. I took a graduate class in it, and we had a problem that we started the class with where we were trying to get the AI through a probability engine to treat a set of data like a mathematical plane. And it was supposed to walk the plane and come back and show us all the edges and all the pieces of that plane of data, except, you know, I thought, well, this is great. You just turn it on at night, let it run, and in the morning, it prints out all these parameters, and you can demonstrate that your AI was able to transverse this plane of data. Except there were these little potholes of probability in there where he would tip into this like little donut hole, and the probability wasn't robust enough to get him out of it, so he would just sit there and spin in this little donut hole. I never got him to traverse the plane of data. Mine was either in the little pothole, or the computer I was running it on was like, you've got to be kidding me. This is this program is huge, you know. It's like swapping in and out trying to compute the first value. So you do find, and you still see it today in the space, these very specialized applications. And when I joined Watson, I had nightmares for, you know, the first few days before I actually joined the team of, oh, geez, you know, I'm a consultant, by the way, if I didn't tell you that. And so my job is to actually take the Watson product line, service line, into clients and help them be successful with it. So I'm not developing the product, I'm taking the product to clients and solving their problem with it. And I had nightmares about, you know, and then we hit the donut hole, and oh, what am I going to do then? Well, you know, that's a very specific, that type of technology would be very specific. That's not what we were after. And you will see, you know, you'll see these interviews with folks who are doing AI, and they've got a bundle of cables, and they'll slap a latex face over the top of it, and it will talk to you and whatnot. That's really not what we're after. The other extreme is folks who have such generic cases. They have large public data sets. There's no personalization or differentiation to it. You can sort of get your AI out of it. Maybe someone, unlike Henry Ford, they will spray paint it a different color for you, and you know, it's your AI, but it's too general. You know, the business clients that I work with want AI that works against their data, right? Works against their data, their business problem. And so how do we go from something where, you know, and my professor would helpfully, you know, got the professors down here, my professor would helpfully say, oh, when it falls in the donut hole, just nudge the probability model a little bit. What does that even mean? You know, how do you nudge it? Well, you just tweak the parameter. It'll be fine. Don't worry. You know. But that's not what we want to do with business and AI, right? IBM did this with PCs as well. We said the recipe thing is kind of interesting, but wouldn't it be great if we could develop a computer that you could put on somebody's desk that they could use for business, right? We're dead again? I can tell people are smiling at me. That usually means your chart died. So that's what we're trying to develop. We're trying to develop AI that can be used by businesses and individuals in a reasonable way. And so what does that mean that we're going to have to develop to do that? Well, first of all, we're going to have to learn from smaller data sets, right? Our clients, these businesses, want us to learn about their data. And we'll talk about why that's important, why that distinction matters. They also want to own their insights. So if they give us data, you know, there may be some pieces of it that they would be fine sharing, but this is their data, this is their business. What you know differentiates you from your competition, and so they want to hang on to that data versus, you know, necessarily having it kind of flow into a greater consciousness. And they also want AI to be a helper. So instead of the AI application, they want AI to be part of everything, right? Can you help me help my employees do their job better? Can you help me help my employees understand the data and information that they have better, right? That's where we're trying to take cognitive technology, AI technology, into the mainstream. And so it's a combination of unstructured and structured data. When I first started with Watson back in 2014, people would call and say, I've got this database table, I'm going to rip everything out of it and put in unstructured data. And I'm like, wow, don't do that. You know, heck, you got it in the table, you can query it, don't throw it away. So it's dealing with combinations of places where you have structured data sets and also unstructured. So unstructured is maybe I have a whole bunch of manuals, I maybe have a whole bunch of trouble tickets, maybe I have photos of various things, And I want to combine these data sets in some meaningful way to help me provide information for these use cases. Also, we may need to do some transformation on that data because not everything that you have in your data set is going to be particularly valuable for your business case. Now, one of the things that my team spends a lot of time on is helping people find the right business case, the right size of data, the right application to apply AI. And we'll talk a little bit about what those parameters look like. And then providing insight into what we find, right? So that's the analytical pieces of it. And we need tools at each of these steps to help us move forward. All right, now you can tell when we have departed from some really nice charts that we use and onto the charts that the fellow developed herself, right? This has that home cooking look to it, does it not? All right. So actually, I can't take complete credit or fault for this one. But what we found when we went out and started working with clients is that not everybody was wanting to play Jeopardy with their data, right? So after we did Jeopardy, we developed Watson as a couple of applications, Watson Engagement Advisor, Watson WDA, the Discovery Advisor. And we had these two products that did various things, but it was basically we need to understand your questions, and we're going to apply those questions to a large swath of data that you have to go discover what is the answer in that data. And you're going to train us, and the training would be kind of on two levels. We need to understand your questions, and we need to understand your data. What we found as we went out and did a lot of work with clients is a lot of them did not need the part about understanding their data. They may say, I have a fairly small set of answers that I want to apply to a lot of different questions. So for example, if I'm setting up an application for a hotel and they want the AI to answer, where's the pool? The pool's really only one place. I don't need to fly over every brochure, every maintenance ticket, everything that they might have as a piece of data. There is an answer. Take a left at the elevators, right? Or take the elevator down to the lower floor, or whatever. There is an answer. In some cases, how do I print a W-2? Perhaps HR says, this is the answer that you need to give them, right? In some cases, your corporate attorneys may feel like this is the right answer to give them. We also found, as we were doing conversations, that pulling random pieces of text out of various documents, even though it may be the best answer to that question, is not the most conversational way to operate. If you say, hi, Watson, and Watson goes, hi, back, and then you say, where's the pool? And Watson goes, the pool is constructed using a special concrete process. And that's something, and we may eventually get to the part where we tell you how to get there, but it's not terribly conversational. Also, it's not terribly conversational if I change verb tenses in the middle of our conversation. Hi, where's the pool? The pool, take a left at the elevators. What time does the restaurant close? The restaurant founded, and again, off it goes into some spiel. So we found that there was a whole set of tests or a whole set of use cases that wanted nothing more than for us to understand the various forms the question could be in, right? And provide an answer, an intent, based on that intent, answer that question, right? Now, we did find that there are places where we have conversations that have very nuanced, large data sets. So how do I clear the paper jam in this particular printer? Well, that with a duplex sorter. So who knows? They may have thousands of different models, and they may have dozens of different options. And so they want me to go into that data and find a document or find an answer that may answer a very specific question, right? So that's a totally different training perspective. I need to train on the types of questions I'm going to get and how to apply them to that data set. Likewise, you know, what permits do I need for, let's see, wetlands with commercial zoning? That can take you through a lot of legal documents to figure that one out, right? So not everybody wants the full set. Not everybody wants to understand how the questions apply to the total data set. Likewise, we found how clients ask questions can be kind of interesting too. So one of the things that everybody always asks is, well, can't you come up with a universal chatbot or universal AI experience or universal search capability for, you name the industry, retail or insurance or financial services, right? And I bet at Fidelity they have some financial service products that you guys use shorthand to talk about them, even though the products may have analogs in other industries, right? So for example, if I am at an insurance company talking about umbrella coverage, maybe that particular insurance agent or that particular insurance company calls it big insurance company full coverage. And so BIC FC, and they just call it the FC, right? So they have shorthand for it. So if I train my data set on the phrase umbrella coverage, the AI may say, you know, then I have to go in and I have to untrain it and retrain it for your specific language, right? So the example here is if I'm in retail and I have a client who has a shirt that they sell, and they sell it in these colors and these sizes. A customer coming in will ask a question about this item very differently than perhaps other people inside the company. So can I back order item 1234113 in size large, color blue, comma, please? Customers are so polite, you know. Could I please have this shirt? Would you please back order it for me? Now, when you get into the call center, they may talk about this item completely differently, right? This may be their biggest seller. So they don't call it 1234113. They just call it 113. Do you have a 113 over there? I need one. Or for a 113, and by the way, when we get into call centers, they are very tightly managed and very tightly timed, right? There is high efficiency in how a call center operates. And so the agents may communicate with each other and they have a shorthand that they use. Can I get a 113BO back order in BL, blue, and a large? She did throw in the question mark. You know. And her friend goes, no, in 113, yellow, green, medium only for back order, right? And that's how they communicate all day long. If you're training them thinking they're customers, when you're actually training an AI to help the call center, you will have a bad experience, right? So when Watson first came out, we had a few clients who said, we said, well, it'd be really great if we had some of the questions that the end user is going to use to train the system. And they said, no problemo. Our salespeople know exactly what the customer asked. And so they went in and they manufactured some questions, and the customers never asked them, right? I don't have to know specifically how they ask them, right? Because I'm going to train the system to operate on a variety of different styles of asking the question, but it would be awfully good to know what they're interested in and some general things about how they might ask for it, right? So learning how the end user operates was a big part of understanding how to make Watson successful in the field. And so we said, well, maybe what we ought to do, instead of having two products and two products that deal with these larger data sets and conversation as one thing, maybe we ought to think about this as services, right? And so deconstructing Watson, which is where we are today. So we went from 4 years Jeopardy, right, to a multi-tenant product that did both conversation and large data. And now we're in the cloud as a service. And it's a deconstructed service. So I have things like discovery, which can handle very large data sets, unstructured data sets, and help me find information in them in a cognitive way. I have conversation service that can operate to tell me what is the intent of your question, and then I can either invoke an answer that you've mapped to that intent, or I can go into a larger unstructured data set and find it, right? We also added some additional services that we thought people would be interested in. When I started in 2014, Watson only spoke English. He now speaks a lot of different things. And when I say he, how many people think Watson is a big hive mind that lives somewhere, possibly in New York? No. Okay, good, good. How many people have dealt with Watson before? How many people have used our services? What? What? Okay. So our services are available on Ibm Cloud. And Ibm Cloud has different options that you can use to look at these services in an account. Also, it's not your traditional software. We don't, you know, we're looking to be on a services model that as you get more successful in building and deploy apps, right, and draw more traffic into it, that's when we're looking, you know, we have a pay-go model for that, right? So you guys should go out on Ibm Cloud and look at our services. We have, you know, we have a student who was getting really good at appealing parking tickets. He was quite talented at it, and he thought, all his friends started asking him about it. He said, I wonder if I could write an app with this. And so he used our services and built an app that guided you through the decision tree and took your answers, understood them, and built your appeal form, basically filled it in for you, and then went out to a mapping service and pulled in a picture of the parking spot where you were wrongly ticketed. Packaged the whole thing up, sent it off to the municipal government. I think they've done like, I'm going to say 230,000 of these at this point, right? You guys are computer science students. What could you do? You know, what could you do if you had, you know, if you were looking at AI, looking at cognitive technology? We've also added some things like empathy, personality insights. Not only do we want to know what you're saying, but we would like to understand if you're upset while you're saying it, right? Does your tone change? Does your voice change? Do the words you use make us think that you're becoming frustrated? Which is about half of the conversations I have involving, stay away from that. So now, if I can handle both these cases rather efficiently. If I have short tail, where I say, turn on my headlights, and by the way, we just announced a partnership with an automotive company where you can take a picture of a button in your car and say, what's this for? And we will recognize the button from the visual photo and tell you, right? Now, the button can only do so many things, you know. I've yet to find the one that says, launch me into this parking spot. I barely have any room on either side. So it can only do so many things. So that's a short tail data problem, right? That's a very well understood answer. It's going to be based on what buttons you have in your console. The other piece of it, which may be, you know, troubleshooting something. So my exhaust is making a rattling noise, or you know, I'm trying to fix this piece of equipment, what do I do? I want it to perhaps scan a larger body of answers and come back with the ones that it thinks are most applicable to my situation, and that requires a little bit more learning and training, right? So we can handle both, and we can handle both with the services, and you can focus your training on your end users, your data set, your client. And that's a little bit different than where we started, but infinitely easier than training it to do Jeopardy just a few years ago, right? So we're trying very hard to bring the technology to a place where it's very usable and can be incorporated into a lot of everyday scenarios. And I mentioned the visual. We have made some acquisitions. One of them involved visual search. We can evaluate pictures relative to training. So the example over here is a series of accidents and their causes. Motorcycle involved. The picture of the motorcycle was kind of a dead giveaway on that one. But we can train flat tire, undamaged vehicle, vandalism, not only providing you a search engine that or a visual recognition capability that looks at photos that you provide relative to a whole vast sea of photos that may be out on the web, but looking at photos that are interesting for your business and training the system against those photos, right? That's what we want to do. Focused cognitive capability. So we've also worked a lot on the tooling because, again, the trick here is not to have, not to need super duper data scientists every time you do anything with your cognitive or your AI, right? We want to be able to manage it from a set of tools that an average person or someone who's trained in how to do the training could deal with fairly quickly. So if you're an expert in call center for automotive claims or retail data or whatever, you're the person that we want to do the training. And so how do we provide tools that help you train and understand your particular documents the way you understand them? And so we've spent quite a bit of time working on Knowledge Studio. And this tool allows you to tell us inside a document, here are the kind of words and kind of things that I want you to understand about this. This is sort of building your lexicon, your understanding, your training around your documents, teaching us, and doing it in a friendly interface over a fairly small set of documents. This is also the thing that Holly is busy working on with us, right? Because, and here's the part, computer scientists. How many computer scientists do we have, by the way? Just rogue engineers. How many of you guys snuck in? All right, there's a few of you. All right, very good. So the problem we have right now is you need a computer scientist to get to your data, right? If you go to companies that are like ours, or if you go to places that use a lot of information technology, I won't call out anybody specifically because I don't know your specific situation, but almost every place on earth, all the people down in the IT department have this huge backlog of things that the business would love to have them do, right? Gee, we'd love to have a program that lets us pull this data and use it here, right? You guys are kind of the gatekeepers and the guardians of the data. You gotta, and not intentionally, you just don't have enough time. There aren't enough of us to sit down and write all the programs that people want to get at their data. What would be super handy is if we could let the people get at the data on their terms, right? Which is what this is headed for. We want people to be able to pick up these tools and say, here's the data that I have. Here, computer, is how I want you to think about my data. Here's how I want to train it. And I want you to respond to my questions about it, my information, right? And so that sort of takes the computer scientists out of the middle. That's the revolutionary part of this, that we can take the middleman out between the end user and the data set that they're after and help them teach us how they want to view it. If the tooling gets good enough, right? If the tooling gets good enough. And that's a long way from my little AI traversing that plane of data and falling into donut holes every day. That is access to a lot of power across the board. Wouldn't it be great if you had an AI that understood your financials, right, and could advise you on, hey, last time you bought one of those, remember they sort of messed up and we had a problem with it, and it understands you and your specific scenarios, your medical history. That would be pretty awesome. And what we're hoping to to start building out. So, we see this as part of a story, right? We have higher level applications here like Unc Oncology, which is the part that is built on some of these services and these capabilities to deliver a higher level function. I want to understand this data relative to cancer research. IBM Risk and Compliance, we now call that compare and comply. So if I can understand large volumes of data and questions asked against it, wouldn't it be kind of cool the next time someone puts a contract in front of you to buy something, or a contract in front of you for employment, if you could feed it through a system that says, tell me, what are all the terms here? Right? What are all the terms? What do I have to do? And help explain that to you. And later in life, if you're working for a large company and you're signing contracts, wouldn't it be kind of cool if you could have it look through this contract and tell you, or look through a bid or a proposal and say, you have answered all the terms, or here's how you answered these terms. Right? Pulling apart these giant complex documents and helping people understand them. And so we also have the cloud infrastructure itself. IBM is doing a lot of work in cloud and how that supports some of these applications and things that we do above. So we talked a little bit about compare and comply. This is a little example of it. It understands from, what's that up there? What kind of document? PDF. Now this isn't like the ugly kind of PDFs that, someone took a picture of it while galloping through the room and out the other side. But it's a fairly well-formed PDF. We can ingest it, break it up into obligations. Here's what you have to do. Here are the rights. Here are the things that are kind of nebulous, the rules of the road things. And here's how you're doing against those. Right? Pretty handy stuff. All built on these services that we orchestrated from understanding data and questions. And of course, we're going to have different folks here. I'm going to scoot this along so we can get to some Q&A. We're going to have data scientists, engineers. We have customers who have people who come in every day and look at, here are the questions that we got. How did we do with these? Is there more data that we need to add to the system? Do we need to change answers based on things that are happening, events and occurrences? So this is a new job that's never existed before, right? How my system interacts with human beings, how's it doing with the questions, how's it doing with the answers? And I'm a consultant, and so I'm not developing the services, I'm trying to figure out how to use them. How many folks have ever heard of design thinking? A few of you, right? So design is huge out in the market these days, and understanding the principles of good design and being able to speak about design thinking certainly would help you. We have these things called garages where we bring in clients and we use the techniques of design thinking to better understand their projects, their data, what they're trying to do, right? Because AI systems, in case you haven't noticed from all the charts that we just went through, they live and breathe off data. And if you try to pick a place to do a project where the data is very thin, it can be really tough, right? If you try to do a project where you don't have a lot of people coming through, so you don't get good training data for it, that can be kind of thin too, right? So sometimes folks try to de-risk their project by picking a small area of their business. We're just going to do AI about this little thing. This little, got the whole fruit bowl, we're going to pick one grape. One grape, that's all we're going to do AI on. Well, we need, through the garages, we can help design and show the client, here is a set of projects potentially that are a good fit for cognitive and AI in your organization. Also, we have been in the field working with clients enough that we have developed our own solutions. We have our own solution assets that people can call us, we can deploy quickly and get assets and solutions stood up for them in a few weeks. And We also have experts that we can send out in the field, right? So if you have a very large unstructured problem, we have experts who are good at going out and tackling that one-on-one. So a couple of stories. One of the questions I got a lot in 2014 when I joined was, is this stuff real? Do people actually do this? And the answer is yes, this stuff is real. And IBM was, you know, again, the thing here is taking this out of a very cloistered research environment where AI lived before. Everybody had heard of it, but who was doing well with it, and who could take this to a business solution? Well, IBM has taken it a long way, right? And we have clients. We have an oil and gas company that we work with out of Australia. They do a variety of oil platforms, but some of them are offshore. They picked a platform that they had 1 million documents for this over its 30-year lifespan. Because here's another moment. Here's another engineering moment, right? So you're going to get out into the field, and not everything you work on is going to be stuff that you started. We call that greenfield. It's never existed before. You're the first to build it, and that has a lot of advantages. You can sort of do with it what you want, right? Whatever you want. But what you will typically find is that you end up owning something that has already been started. And that's a little bit harder and not as much fun, right? Because it's working, but, you know, gosh, if I could only go back and change this, there, or the other. Things also work as systems. So a large oil platform is a system. Every valve is important. Every pipe, everything in there has a purpose. And if we see one thing having a problem, if you're very experienced at that thing, you may know, when that thing goes south, when that particular valve is under stress, it could mean that this thing over here failed. But this thing doesn't necessarily show up first. It's usually this, because it's the weaker piece, right? And so the experienced engineer will go swap out both pieces. The new engineer will keep replacing this one and not understand why it keeps failing all the time, right? And then this blows eventually, and it might be a much bigger problem. Okay, so we got the 1 million documents. We got the data from 80,000 sensors. We also got 30 years of engineer experience to train us on what these documents mean, right? So when I have a trouble ticket on this, you should also go look at that. You should pull them back the information about this particular set of valves too when you get a question about this one. Right. Some of their employees delayed their retirement in order to train Watson. They felt it was that important. And that's extremely valuable, right? Large computer systems behave the same way. These things I did for Black Friday, I could walk up to the dashboard of the monitors for it and say, you know, the file system looks a little hot here. What's happening with this component? Because I knew from working in this particular piece of software or working for this client that when I saw that disk get hot, it could mean 3 or 4 things because I had experience. New people coming onto the project would not know that, right? And also a bank. This is, we have a client in South America. They have 60 or so financial products that they sell to end user consumers. They have branches, they have employees, and trying to understand these products. When you come in and say, I want to plan for my child's college. They can type in some information and Watson helps them. Almost. It's thinking. It said, it's getting close to 7. You should stop talking now. Hang on. Oh. That was my ace in the hole. You got a quick glimpse of it. Dang. All right. So it's in Brazilian Portuguese. We have a lot more languages now than when I started. Variations on Spanish and whatnot. Portuguese, a lot of different languages that we work with to help the person at the bank pick the right product for you based on your criteria. And we're working with you guys, puppies, You know, a chart with puppies, my goodness, what could be better? To evaluate guide dogs using Watson technology. It turns out puppies aren't really good about sharing their emotions. So the animal can be under stress, but it looked perfectly happy. But by picking up some sensor data and other behavioral data from the animal, we can tell that that puppy is kind of stressed out. The dropout rate for animals in these programs is quite high. If you can pick the animals early on that are going to succeed, it certainly saves a lot of money. And think of how de-stressed the puppy is. Whew, I can just go be a family pet. I'm so relieved. This was so stressful. But seriously, it's a huge help and a huge financial pickup for the folks who do this really great work. And so what's next? Well, you look at this. I looked at this picture and I thought every person here in this picture, every dot of light, there's probably somebody there with a smartphone or a smart device, right? They have computer access. If you had told us when I was going to NC State that that was going to happen, I would have said, not this quickly, right? This is science fiction. And I have to tell you, working with Watson every day seems like a science fiction episode come true, right? I wake up in the morning, I'm like, I wonder what it can do today, because I went to bed and I get up and it's way smarter than it was the night before. You know, we've learned languages, we can do images, we have applications, we're tackling hard problems, we are dealing with files that 2 years ago I would have said, I'll tell the client, no way, we can't do those kinds of files. Now we can, right? Everything that we've said, you know, that's a blocker to us out in the field. The development team has said, thank you very much, we'll be right back, and they come back with that fixed. So the progress, the speed in this space is extraordinary. And I'm really jealous of you guys. I say this everywhere I go in regards to recruiting and things like that, but you know, we got to see the PCs up to the smartphones. We got to bring everybody off of having to call people who had access to terminals, and now you just have direct access, right? You just do it from your phone. And so making the world web-enabled, making the world, bringing democracy to access to your data as it currently exists, that was my generation's gift to you. But now, you've got some really cool stuff that you're going to get to do that's way cooler than what I could do, right? You've got this data, you've got this amazing infrastructure, you've got a lot of computing power in everybody's hands. What can you do with it? Where are you going to take us with it? It's going to be extraordinary, and I'm really jealous because that seems sort of like old news now compared to where you're going, right? What you can do in partnership with cognitive and AI, because the computer doesn't need to know computer science languages anymore, programming languages. It can speak your language, your human language. That barrier's gone. And so now what do you do with a computer that powerful? You know, we have some sci-fi scenarios in that space, but I think the actual scenarios that we found and how it can help humanity are extraordinary. Think about people who with poor rates of literacy. You can just speak into a phone now and access a computer that has access to extraordinary data and capability. You don't even have to know how to type. Use a keyboard, use anything. You can speak to it. That's extraordinary. So I look forward to what you're going to do. I look forward to being part of the beginning of that. But you have entered into this world at a very interesting time, and I hope you appreciate that and hope you're thinking about how revolutionary this stuff is and what you could do with it. So I have run over. Holly will tell you it's easier to get me to start talking than to shut up. But can we do a couple of questions, do you think? No, he's giving me the look, no.